So today we're learning about magnets. And I'm going to read you this book called What Makes a Magnet. What Makes a Magnet by Franklin M. Bramley. Let's go fishing with a magnet. Put different things in a box. A twig, some tacks, a needle, paper clips, and rubber bands. Bits of paper and aluminum foil. A pin or two. What else? You decide. Choose the things that are small and light. Next, find a magnet. They come in different shapes and sizes. You see all the different magnets?
Yes.
We have some right here, you see? You want to hold it? Tie on one end of the string around your magnet. Tie the other end to a stick or a pencil. This is your fishing pole. Go fishing in the box. Put the things you catch in a pile. The other things will stay in the box. I've got a nibble! Maybe you caught the tacks, paper clips, needles, and pins, but not the rubber bands and aluminum foil. There's a reason why only some things stick to the magnet. They have to be made of the right stuff. The material they're made of has to be magnet sticky, or whatever word that is. Anything you lifted out of the boxes probably has iron in it. The iron in these different objects is ferromagnetic. The iron is not only ferromagnetic material, but is most common. Which objects in the box do you think are magnetic?
The coins.
Very good. That's a very good observation. So, now that we have finished the book, I want to see if you know, by looking at this paper, yes, you can see it. This paper, tell me which ones are magnetic. So the first one's a paper clip.
The paper clip is magnetic.
You think so?
Mm-hmm.
Here, I want you to write down, circle the ones you think are magnetic. All right. So my student here has circled 3 of the 6 things that we have on the paper, and we're going to see by experimenting with some of the things I found at home if she's right. So now we're going to use these materials that I have here on the table, and she's going to use a magnet and see which ones go in magnetic or non-magnetic. Or you can use the one you have already. You can start. So here's magnetic and here's non-magnetic. Ooh! Read it once. So what was that wasn't magnetic?
Sugar.
All right. So why do you think the penny isn't magnetic? Think about it. What is the penny made of? Copper?
Yes.
And what is magnetic things have to be made out of? You just learned in the
Metal.
book. Huh? What kind of metal? Is that in the book? Iron?
Iron.
There you go. So this is made out of copper, so therefore it's not going to be magnetic. So that goes in the non-magnetic. So none of the coins have iron in them, so you can go ahead and put those in the non-magnetic. Alright, so the last thing, what is that made out of?
Plastic.
Right, so that would be non-magnetic. Okay, so now that my student has completed separating all these items into the magnetic and non-magnetic, I'm going to have her create her own magnet that is going to look like this. So she will put on the magnet the things that she thinks is magnetic, and the things that are hanging from the magnet are non-magnetic. And she has all the supplies she needs, so we're going to do that real fast. Use scissors. You start by cutting out that. Okay, so you finished that part?
Mm-hmm.
Now you can cut out the parts that she has to glue onto that. You're gonna glue them all, but they're not all gonna go on this. All right. So while you're, what I want you to do is I want you to put one stack for magnetic and one stack for non-magnetic. And while you're doing that, I'm gonna cut out your pieces of yarn. Okay, so you have them separated?
Mm-hmm.
Now what I want you to do is to put the non-magnetic ones on your non-magnetic paper. So you're gonna put, you should have a total of 6 for non-magnetic. I want you to put 3 on each paper. You can glue them and they should look roughly like this. And you have 2 pieces of paper here, and then we'll cut those papers out in a minute. I'll glue these onto your magnet.
only put 3 or did I put all 6?
3 because you need to. Yeah, you can glue it. Okay, so then go ahead and do that for the other piece of paper also. Okay, now I want you see how this is cut out like a square?
Mm-hmm.
Go ahead and cut those out for those papers. Alright, so this is gonna go, this is gonna go like this. Okay, so I want you to have that down like that, have that down like that, and then take these on there evenly. So it'll be hanging down just like mine. Here's the tape. Okay. All right, I'll turn it over. So now you have your not magnetic stuff down there, right?
Mm-hmm.
So now I want you to, however you can fit it, just make sure the words are showing on this little piece of paper. However you can fit all of them right here. Go ahead and try. As you can see, mine are overlapping.
Mm-hmm.
So.
Glue on?
Mm-hmm. Alright, so that, I just need to take a picture of it, and that is yours to take home.
Okay.
So now, I want us to watch this short little video, and then we'll do a conclusion. Alright. The video's about 3 minutes long.
Okay.
Ready?
Mm-hmm.
Hey, hello guys. Meet my friend, Miss Magnet. Whoa! So you guys already know each other. Very well then. That makes life easier, as I'm going to be talking about magnets and magnetism today. Zoom in! Magnets are magnificent objects that create an area of magnetic force around them, which is invisible to the human eye. This area is known as the magnetic field. If a magnetic object is inside that area, it gets attracted towards the magnet and moves towards it without any physical contact. Looks like magic, isn't it? Now, what's a magnetic object? Objects that get attracted to a magnet are called magnetic objects, and the objects that do not get attracted to a magnet are called non-magnetic objects. For example, a piece of wood or cloth won't even move if kept near a magnet. But objects that contain iron, nickel, and cobalt will definitely get attracted to the magnet. When you keep a magnet freely suspended in air, it would rest in the north-south direction. The end that points to the north is called the north pole of the magnet, and the end that points south is called the south pole of the magnet. Well, I have a fun experiment for you. Take these two magnets. The north and south pole should be marked on these magnets. Now, bring the like poles near and see what happens. There you go. These magnets repel each other. Now, bring the unlike poles near. See? The magnets attract each other. This proves that unlike poles attract each other and like poles repel each other. Hiya! Well, if you cut a magnet into two, it won't lose its magnetic field, but would give you two new magnets. Trivia time! Did you know that the Earth behaves like a magnet? That's because the Earth's core is believed to be a mix of iron and nickel, giving the Earth its own magnetic field. If a magnet has a strong magnetic field, it can pull objects even underwater. Tune in next time for more fun facts. This is me zooming out.
Okay, is there two things you can tell me that you learned from the video?
That the Earth's core is made up, well, believed to have,
Magnetic fields in it, right?
yes.
Okay. What else?
And,
what we think happened is one day when we were at school and worked, caramel must have
if you put the two, north poles together, it doesn't
That's right.
attract, you have to do the opposites.
And then can you tell me, give me an example of how you could use a magnet in everyday life, or how they are being used.
You can use them to find things that you've lost, like in like a couch or something.
Just one other is fine.
The things that people use on the beach to find stuff that are
Oh yeah,
magnetic.
I've never even thought about that, yeah. So that's a good one. So we're gonna do one last activity. I need you to stand up. And stand in the middle. Do you want to take this one? Alright, So I want you to move to the left. Oh, sorry, that's your right. I want you to move to the right if it's magnetic, and I want you to move to the left if it's not. Okay? A bottle. Plastic bottle. That's magnetic?
No, it's not right.
Okay, yeah.
Okay.
The right is not magnetic.
Okay.
A paper clip. Alright.
Magnetic.
Yeah. A car.
Magnetic.
Alright. Tape.
Non-magnetic.
Uh-huh. And let's do one more. A penny.
Non-magnetic.
Good job. Let's see here. A leaf.
Non-magnetic.
And a pen. A push pen.
Magnetic.
Yep. Alright, you can sit down. That's it for our lesson today.